Okay. Hi, everybody. A very good evening. Still people are ready to join? Is it?
Yes, sir.
Okay, fine. Okay, we'll wait for 2-3 more minutes so that you people join. Okay, that's it. Everybody's here. Shall we start? Or everybody's ready to join? Guys?
No, I guess we can start, sir.
Chalo, Kanna, we'll start. Okay. Okay. This is the PPT. Is everybody able to see? Or you want me to little zoom in?
It's fine, sir. We can see.
Okay, I think this is better. Right. Okay. Right. We have already done this so many times. We'll just quickly do this. Okay. The following reaction is an example of what? Now you see that. Wait. Let me just. Okay. Right. So the following is an example of what? NH3 plus O2 giving NO plus H2O. Now what you see is happening, it is neither combination, neither displacement, neither neutralization. Right. So definitely it is going to be okay. Okay. We'll see how what other things are happening. Now you see hydrogen was with nitrogen and oxygen now is with nitrogen on the product side. Is it not? And same way, hydrogen was here and that is combined with oxygen. So can I say this is definitely a displacement reaction for sure? Because oxygen has displaced hydrogen from the molecule. NO is getting formed from NH3, right? And also, if you see what happened to nitrogen here, nitrogen has lost hydrogen. Is it not? Nitrogen has lost hydrogen. So can we say that nitrogen is getting oxidized? Right? Nitrogen is getting oxidized, right? And what is happening to oxygen? Oxygen didn't have hydrogen in the reactant side, but in the product side, it is having a hydrogen. So can I say oxygen is getting reduced? Right? So you see that both oxidation as well as reduction is happening in the reaction. So it should be displacement and redox reaction both. So 1 and 3.
So why is it not a double displacement reaction?
Double displacement, both the cation and anion should change. Only one thing is changing here. That is O2, oxygen is getting replaced with H2, hydrogen. That's what is happening. Nothing else is happening here, isn't it?
The hydrogen is coming and attaching to oxygen as well, right?
What kind of?
Hydrogen is being added to oxygen as well, right?
Correct. But what is getting displaced here? From nitrogen, what is getting displaced? Hydrogen is getting replaced with oxygen. Right? Here I have nothing. Here only oxygen is there. Is it not? We cannot say oxygen is getting replaced with hydrogen. That doesn't make sense. Right? In this molecule, hydrogen is getting replaced with oxygen atom, but the other side, nothing is happening. Are you able to get the point? Yes? No?
Yes, sir.
Oh, right. Good. Next question. Okay. Identify which is not an oxidation reaction. Corrosion is definitely oxidation, right? Because I have Fe reacting with H2O and your atmospheric oxygen to form what? Fe2O3 dot XH2O. Is it not? So iron had no oxygen here, iron is having oxygen here. So this is definitely oxidation for sure. Right? Okay. Rancidity is again going to be an oxidation only, right? Because we understand that the food substances gets oxidized and that's why they are becoming rancid. Right? This is also oxidation. Combination reaction might be oxidation, right? Because if at all I have C plus O2 giving CO2, this is a combination reaction. Carbon is actually getting oxidized, right? Whereas double displacement will be a redox reaction, right? Because something will get oxidized, something will get reduced, or sometimes nothing will happen also. Neither change, no redox reaction also will happen, just double displacement will happen, right? So definitely D will be the correct answer for this question, right? Now, moving on. What is the formula for plaster of Paris? Obviously, it is going to be calcium sulfate hemihydrate. That is CaSO4 at half H2O. That is very simple. Moving on. In the reaction CuO plus H2 giving Cu plus H2O, the reducing agent is, now it's very simple. Whichever is getting oxidized is what is a reducing agent. Is it not? Now, copper, you understand that copper was with oxygen. Now, copper is removed. From copper have removed oxygen. So, copper is said to be reduced, right? Whereas, look at hydrogen now. Hydrogen is the one which doesn't have oxygen here, but in the product side, we have added hydrogen to added oxygen to hydrogen. So, this is what is getting oxidized. So, definitely, this would be your reducing agent. So, answer would be H2. H2 is the one which is undergoing oxidation. So that will be the reducing agent. Right? Okay. Moving on. Right. On putting a few drops of liquid on the pH strip, the color of the pH strip changes to green. The liquid just give me 1 second. Yeah. Just give me 1 second, guys. Okay, so they're telling that the pH of the solution is becoming, the pH strip is becoming green, right? So now the liquid taken is likely to be, okay, we'll check. The pH paper shows green color as water is neutral. It's not us, it's is neutral. Dilute sodium hydroxide solution, dilute hydrochloric acid solution, and lemon juice. What do you think is happening here? You have to understand how the universal indicator, this is a universal indicator, right? I will just show you what are the colors. Right? Universal indicator color chart. Some other thing. Yeah, this will be better. Okay, I don't know whether you're able to see it. So where is the green color here? Green color is here. Are you able to see my cursor, guys?
Yes, sir.
Right, the green color is here. So definitely that is going to be neutral. Right, that is what you have to understand. So this side, red color and all, red to a lime green, it is going to be acidic. And if at all it is going to go more and more, it is going to become blue when I'm going to have basic solutions. That's how it works. Right? Okay, so can I freeze the answer now? Right, the answer would be what? A. Right, the pH shows green color because it is water and that is neutral. Right? Next question. Okay. The following pair substances are available in the laboratory. Okay, zinc and dilute hydrochloric acid, zinc and sodium hydroxide solution, sodium bicarbonate and dilute hydroxide solution. Right? Which of the following can be used to produce a colorless and odorless gas which gives a pop sound on heating? What are we talking about? Are we not talking about hydrogen gas? Is it not? Right? Fine. So now we'll write the reaction now. Zinc plus HCl will give me ZnCl2 plus H2. Obviously, this is giving, right? What about sodium hydroxide? This also will react. It will form NaZnO2, right? Plus H2. Again, hydrogen gas is coming out. Excuse me. Right. And sodium bicarbonate and dilute hydrochloric. Now what happens? Sodium bicarbonate is NaHCO3 plus HCl will give us NaCl plus H2O plus what will come? Carbon dioxide gas will come. Right? That is not going to give me any H2. So answer would be only A and B.
Yes, sir.
Right? Now, next. A factor not affecting photosynthesis. Carbon dioxide concentration is there. Definitely it happens because carbon dioxide is required for photosynthesis. Temperature definitely matters. Wind velocity and light intensity. Light is required, right? At night, we cannot do photosynthesis. Only in the mornings and daytime, we can do photosynthesis. So light also matters. Temperature matters. This matters. But wind doesn't matter. Wind velocity.
No, sir.
Not. Right? That does not change how much photosynthesis is going to happen. Right? So option D will be the correct answer to this question. Next. What is the correct about human kidney? Each kidney has two. What is this? I think this is a biology question. What is the answer, Kana? I don't know. What is the answer?
It is bean shaped.
It is bean. That is correct. It is bean shaped. Anyway, this is not a chemistry question. This is a biology question. Moving on. Oh, this is also. Everything is biology. Okay, that's it. Chemistry is done. Right? Everything after this is biology. Right? Check.
Not like that, sir. It's next.
No, sir.
We'll check. Tongue receptor.
I guess next is 22nd question.
Yes, so it's related to chemistry.
Okay. Right. This question only, right? Write the chemical formula of washing soda, how it is obtained from basic soda. Name one industrial use of washing soda other than washing clothes. right? So washing soda, I know the formula is Na2CO3.
Na2CO3 dot 10H2O.
Yeah, 10H2O, absolutely true. Right? How it is obtained from baking soda? Now,
By
obviously,
heating.
what you have to do? You have to heat it, nothing else. Na2CO3 on heating will give you NaHCO3. On heating is going to give you Na2CO3. Right? Name one industrial use of washing soda other than washing clothes. What is it used for? I mean, Na2CO3. Any idea?
Manufacturing glass.
Yes, absolutely. Yes, true. Very true. Manufacture of glass, it is used in. Very good. Very good. Next. What are the okay, this is again another question. Functions of relay. This is chemical physics. Define power of
27,
relay.
sir, next one.
27. Okay. Explain the following in terms of gain or loss of oxygen with two examples. Oxidation is gain of oxygen, right? And reduction is loss of oxygen, right? We'll say some examples, right? Say, for example, gain of oxygen C plus O2 giving CO2 is gain of oxygen, or say H2 plus O2 giving H2O is again gain of oxygen, right? Okay. Now reduction, say, for example, loss of oxygen we have to speak, right? Say, for example, if you have Na2O plus HCl is going to give me NaCl plus H2 gas will be a water, and H2O will be a water. Now, what are you seeing? From this, we have removed oxygen, right? Another example, can we check? Say, if you have any other case where I can, CuO plus H2 gives Cu plus H2. Again, what are you seeing? Oxygen is getting removed. That's another example, right? So many examples you can give. This is the example I am giving. You can give empty number of examples. Okay, right. Next another chemistry. Sugandha prepares HCl gas in a school laboratory using certain chemicals. She puts both dry and wet litmus paper in contact with the gas. Right? Name the reagent used by Sugandha to prepare HCl gas.
Hydrogen and chlorine gas.
Name the reagent used by Sugandha to prepare HCl gas. There can be so many ways to prepare HCl gas. Okay, we'll come back to this question. We'll answer this question. State the color change observed when dry and wet litmus paper. In dry, nothing happens, no change, right? Whereas wet litmus paper will change to what? Will change to
Red.
Blue to red.
Blue to red, right? Because you understand that this HCl gas cannot give me H plus. This is not possible. But whereas HCl aqueous solution, this will only give me H plus. Gas cannot give me H plus. Okay, it is HCl aqueous solution. That means obviously I need to have some amount of water. Only wet litmus paper has some water, so that only will give me H plus. Okay. Show the formation of ions when HCl gas combines with water. That's very simple, right? HCl will react with water. Now, what is going to happen? This is going to donate H plus to water. So what is going to happen to water? Water is going to produce H3O plus. And what is remaining if I remove H plus from this? Cl minus will be remaining. So HCl plus H2O gives H3O plus Cl minus. That is what you have to use, right? And this question, name the reagent used by Sugandha to prepare HCl gas. What is this? There can be so many ways of preparing this. Hydrochloric acid. Okay, we'll check.
So HCl gas, right, sir?
This is loading. Just give me a second. Yeah, it's HCl gas. Now you can see this apparatus. If you check, right, we are going to have concentrated sulfuric acid. Right, if I can just zoom it to you, why is it changing? Sorry, this one. Okay, if you can just see that, you see that sodium chloride is there and concentrated sulfuric acid is there. Now, if they make them react them both, what is going to happen? Now, this Na, that what is the Cl will be attaching with H, and you're going to get what? You are going to get HCl gas out. Okay, so the reagent used are what? NaCl plus H2SO4. If I can write the reactions for you, right? This is how the reaction is going to look. NaCl plus H2SO4 is going to give you HCl plus Na2SO4, and this will be a gas event. Okay, right? Fine. Next. Okay, this is not the part of chemistry. This is also not part of chemistry. This is also not
The
part of
34th question, sir.
34.
4, sir.
34. No. This is okay. A compound A dissolved in water gives B, liberates heat. Okay, it is going to be an exothermic process. Compound A is used in whitewashing. What is it? So can I say it's CaOH, CaO? Is it not? Whatever is used in whitewashing is what? CaO, quicklime. Right? That's it. We got the answer. So CaO reacts with H2O to produce CaOH twice plus heat. This is an exothermic chemical reaction you would have seen. The test tube becomes hot. Right? And compound B, that is CaOH twice, will react with Ca. This is your lime water turning milky. CaOH twice reacting with CaCO, to form CaCO3. Right? A white precipitate. This is your white precipitate C. This is your A. This is your B. This is your C. That's it. And we are done. Write the equations involved. We wrote the equations also. Okay. Next. Define nutrition. Diagram should okay. This is physics. Okay. Copper sulfate crystals contain water precipitation when the crystal is what? Copper sulfate crystal contains water precipitation when the okay. This is full stop. When the crystal is heated, the water precipitation is removed and salt turns white. The crystal is moistened again with water. The water crystallization is the fixed number of water molecules present in one formula unit of copper sulfate. Right? On heating gypsum at 373 degrees Celsius, it loses water molecule and becomes calcium what? What is this question?
The next slide is a continuation, sir.
Oh, that says continuation only. Okay. Oh, it becomes calcium sulfate hemihydrate. Okay. If the crystal is moistened with water, the color of the crystal reappear. The color of the dash color of the crystal reappears. Okay. We need to know what is the basically what they're trying to say is that CaSO4.2H2O on heating gives what? CaSO4.5 H2O. Right? What is the color of Ca? The color of the crystals appears.
So they are talking about copper sulfate.
Oh, copper it is. Oh, okay. What was it? Yes. And I asked they are on heating gypsum only, right? Gypsum is CaSO4.2H2O.
But the diagram shows copper sulfate.
1 second. Oh yeah, copper sulfate crystals, right? So test tube holder boiling, okay, fine. If the crystal is moistened with water, obviously what color is going to come back? Blue color is going to come back. That is easy, right? Okay. What is the commercial name of calcium sulfate hemihydrate? That is CaSO4.5 H2O. We know it is plaster of Paris, right? Okay. Next. Right. Dash water molecules are present in the copper of this thing. I know it is CuSO4.5 H2O. Right. So the answer would be what? 5. On heating gypsum at it becomes what? It becomes CaCO3.5 H2O. right?
So
That is-
CaSO4.
sorry. CaSO4 or half H2. It's D is the answer. Absolutely. Right. Next. The salt which produces water in solution is in solution. Baking soda is NaHCO3. Gypsum is CaSO4.2H2O. Washing powder is different. Bleaching powder is different. Right. The salt which produces water in the solution is what then? Only gypsum. CaSO4.2H2O. Right. Okay. Next.
That's all, sir.
Biology. That's it.
Yes.
Yes, sir, that's it.
That's it. Okay, people. Right. Any other questions you have? You want to ask me?
No, sir.
Okay, then. Right. We'll see you. I think the next class. Thank you so much.
Thank you, sir.
Thank you.
Thank you, sir.
Thank you.